In this lesson, we will derive half-angle and triple-angle trigonometric identities from the basic identities in trigonometry. Let's get started with the first one. Now consider cos of alpha. Since cos alpha is equal to cos alpha by 2 plus alpha by 2. So 1/2 of alpha plus 1/2 of alpha makes cos alpha. If we expand expression on the right side using cos alpha plus beta, this will become cos alpha by 2 times cos alpha by 2 minus sin alpha by 2 times sin alpha by 2. Means we have cos alpha equal to cos square alpha by 2 minus sin square alpha by 2. And if we want to derive trigonometric identity, half-angle trigonometric identity for sin alpha by 2, we should replace cos square alpha by 2 by its equivalent in terms of sin. This means cos alpha is equal to 1 minus sin square alpha by 2 minus sin square alpha by 2 using fundamental trigonometric identity. So this is equal to cos alpha equal to 1 minus 2 sin square alpha by 2, or we can write 2 sin square alpha by 2 equal to 1 minus cos alpha, or we can also write it in the form sin square alpha by 2 equal to 1 minus cos alpha divided by 2. And now if we take square root on both sides, this will give us sin alpha by 2 equal to plus minus square root of 1 minus cos alpha divided by 2. So this is half-angle trigonometric identity for sin. Now we will derive half-angle trigonometric identity for cos using equation number 1. So number 2, using equation 1 where we proved that cos alpha is equal to cos square alpha by 2 minus sin square alpha by 2. This time we want to derive half-angle trigonometric identity for cos alpha by 2. Therefore, we will be changing sin square alpha by 2 in terms of cos. This means cos alpha is equal to cos square alpha by 2 minus 1 minus cos square alpha by 2 by using that fundamental trigonometric identity cos square theta plus sin square theta equal to 1. If we use this, and we can write cos alpha equal to cos square alpha by 2 minus 1 plus cos square alpha by 2, which gives us cos alpha equal to 2 cos square alpha by 2, 2 cos square alpha by 2 minus 1, which means 2 cos square alpha by 2 is equal to 1 plus cos alpha. And these results are very frequently used in questions. So remember these half-angle trigonometric identities. Cos square alpha by 2 is equal to 1 plus cos alpha divided by 2. And if we take square root on both sides, this will give cos alpha by 2 equal to plus minus 1 plus cos alpha divided by 2. So this was second. And now if we want to derive Third, for tan alpha by 2, since tan alpha by 2 is equal to sin alpha by 2, sin alpha by 2 divided by cos alpha by 2, and we already have derived half angle trigonometric identities for sin alpha by 2 and cos alpha by 2. This means we can substitute those values. So tan alpha by 2 is equal to, so this was plus minus. For sin alpha by 2, we have calculated 1 minus cos alpha by 2 square root. So this is 1 minus cos alpha divided by 2, and similarly we have here is 1 plus cos alpha divided by 2. Obviously the common denominator can be cancelled, leaving behind tan alpha by 2. Tan alpha by 2 is equal to plus minus 1 minus cos alpha over 1 plus cos alpha. So these are three half angle trigonometric identities, and now we will try to find triple angle trigonometric identities. So this is number 3, and now let's go to number 4. In number 4 we are going to prove sin 3 theta is equal to 3 sin theta minus 4 sin cube theta So let's take left hand side and expand it. Sin 3 theta is in fact equal to sin 2 theta plus theta. So sin 2 theta plus theta, we can now apply basic trigonometric identity sin alpha plus beta. So this will be sin 2 theta into cos theta plus cos 2 theta into sin theta. Now the trick is, if keep an eye on what you want to prove. The expression on right hand side which you want to prove involves only sine. There is no cos involved on the right side. Therefore, whenever you have a chance, you should convert your simplifications in terms of sine. That's why sin 2 theta can be written 2 sin theta into cos theta plus cos 2 theta has 3 formulas, but we will be only using the one which involves only sine. 1 minus 2 sine square theta into sine theta. So this is equal to 2 sine theta into cos square theta plus sine theta minus 2 sine cube theta. Now you can see I have cos square theta here, which obviously I can convert into sine very easily by using fundamental trigonometric identity. Therefore, this will be 2 sine theta into 1 minus sine square theta plus sine theta minus 2 sine cube theta. And now everywhere there is sine. So this is 2 sine theta minus 2 sine cube theta plus sine theta minus 2 sine cube theta. And now adding up the like terms. So this will be 3 sine theta minus 4 sine cube theta, and this is exactly what we wanted to prove on the right hand side. I guess you have learned the trick, but let's also prove triple angle identity for cos as well. and this will be number 5, I guess. Cos 3 theta is equal to cos 2 theta plus theta, and we can use cos alpha plus beta formula. This will be cos 2 theta into cos theta minus sin 2 theta into sin theta, and this will be, because what we want to prove involves cos only, that's why we should make every effort to convert cos 2 theta in terms of cos. So here we have 2 cos square theta minus 1 into cos theta minus 2 sin theta cos theta into sin theta. So here we have 2 cos cube theta minus cos theta minus 2 sin theta sin square theta into cos theta, and now we can convert the sin square theta in terms of cos again. So this is 2 cos cube theta minus cos theta minus 2 into 1 minus cos square theta into cos theta. And therefore we can simplify 2 cos cube theta minus cos theta minus 2 plus 2 cos square theta, and there was cos again, minus 2 into 1 minus cos square theta. So this is 1 minus cos square theta into cos theta, and we can do this 2 cos cube theta minus cos theta minus 2 cos theta and plus 2 cos cube theta, and now we can add this and 2 cos cube theta. This will give us 4 cos cube theta minus 3 cos theta, and that gives the proof. And similarly, I hope you can do it for tan number 6. Tan 3 theta. Tan 3 theta is equal to tan 2 theta plus theta, and you can expand it by tan 2 theta plus tan theta divided by 1 minus tan theta into tan 2 theta, and this can be opened by using double angle identities. Here this is 2 tan theta over 1 minus tan square theta plus tan theta over 1 minus tan theta into 2 tan theta over 1 minus tan square theta. So this will be equal to 2 tan theta, 2 tan theta plus tan theta into 1 minus tan square theta over 1 minus tan square theta minus tan theta into 2 tan theta. And here we have the denominator 1 minus tan square theta, tan square theta, and here again we have the same denominator 1 minus tan square theta. So these can get cancelled and we are left with 2 tan theta. This is 2 tan theta plus tan theta minus tan cube theta over 1 minus tan square theta minus 2 tan square theta minus 2 tan square theta. And now adding up the like terms, we will have 3 tan theta minus tan cube theta over 1 minus 3 tan square theta. So these are the triple angle identities, and we'll see you in the next lesson.